Hello and welcome to the Unnamed Reverse Engineering Podcast. I am Alvaro. Today with me is my co-host Jen, and our guest is Willem Melchin. Welcome to the show, Willem.
Thank you for having me.
Welcome, and congratulations, Alvaro.
I did it first try. So yeah, thank you so much for joining us today. Can you tell us a little bit about yourself? We read some of your articles on car hacking, and we're really excited to talk to you. So I guess to get started, can you tell us a little bit about your background in reverse engineering and such?
Sure. Yeah, I mostly started out with just electronics development. I started out with Lego Mindstorms when I was a kid. That's how I started with the programming. I had like the yellow brick that you have to program with an IR transmitter, and it took forever. And then I wanted to make my own stuff, and then I learned about PIC microcontrollers. So I started programming those in BASIC. There was like this, my English wasn't as good back then, so there's this Dutch website that explained how you could program that in PIC BASIC, and I built my own programmer. And then at some point, the BASIC became a little bit limited, so I switched to C, and that's kind of how I started real programming on PIC microcontrollers. I started building these electronics projects. And then in my last year of high school, we had to build this like big project. And then I built this autonomous sailing robot.
That's pretty cool.
It was I had like this ARM microcontrollers, like this the embeds board on it, and I had like a GPS and a compass and all of that.
So it sounds like, and sorry to interject, and in general, there's just two people in the world. There's PIC people and AVR people, and I'm assuming you're a PIC person.
Back then I was. I kind of made the wrong choice, I must say. I think I got into it because of this Dutch website that explained it all, and this programmer, and I kind of regretted this later.
Can we take one step back? We asked him like for his whole background, but we never even give him a chance to say who he is and what he does.
If you want. Sorry about that.
Might be good to give some context to where we're going to end.
I'm Willem, and I work at comma.ai. I'm the head of openpilot, which is an open source self-driving car software project.
Nice.
So that's what I do as my day job, and in my spare time, I like reverse engineering cars.
So it's like the freshman university college course where you're supposed to usually design an autonomous vehicle, and you've just made a career out of it.
Yeah, kind of.
Okay. That's pretty cool.
Nice. Okay, so eventually you got to embed.
Yes, yeah. So I mean, what I was going to say is like, how did I start with reverse engineering? So I basically started out with building things, and later I realized that was super useful if you try to reverse engineer something. That if you figure out if you know how to make it, then it's a lot easier to reverse engineer it. So I started out with mostly embedded stuff, and I also did some just general programming, websites and stuff as a hobby.
Yeah, nice. So then where was the big leap? Like, I guess. So it sounds like to cars.
So I did a bachelor's in electrical engineering. Still more electrical engineering. So I did some, just regular electrical engineering stuff. I really like the VHDL and like the control stuff.
Mm-hmm.
And then I did a master's in control systems.
Mm-hmm.
And then I decided that control systems was super useful for self-driving cars. I've always wanted to go to the US, so I started applying for an internship at all these self-driving car companies.
Mm-hmm.
That's how I kind of ended up at comma.ai.
Okay.
And I started out as a controls engineer, and then I transitioned more and more into software.
Oh, cool.
Okay, so at least in university you spent most of your time kind of doing VHDL, building out control systems and so on. Definitely not doing Verilog.
No.
Those are the other two types of people.
I mean, it's Europe, right? It's mostly VHDL.
At university level, that's what I learned was VHDL. It wasn't until I left and went into industry that I even saw any Verilog.
Here in the US, they say it's more of an East Coast, West Coast kind of thing, where like the East Coasters will do VHDL or something like that, and then Verilog
very
over
Tupac,
here.
Biggie Smalls type beef here. I had no idea.
Yeah, so I did my internship at Comma, and then I went back to finish my master's degree, and then I kind of got into the whole CTF thing. I didn't really know that those things existed. I found ones like, oh, this looks like an interesting puzzle.
Yeah.
And that was like, it was kind of hard enough, but not too hard. So even as a novice, you could get into it. And it's like, and I got kind of hooked. It's like the dopamine rush when you solve one of these challenges. Like, I want to do the next one.
Yeah, which CTF was it out of
I'm
curiosity?
Curious.
Yeah, I don't remember exactly what it was. It's a good one, but
was it a car manufacturer or was it just a very generic?
No, it's just a general one. It was like some software and some hardware stuff.
Okay. Was it a satellite?
Hackasat. I got my Hackasat shirt on today.
Oh, nice. Yeah, I just kind of like that. Yeah.
Yeah, it's been my only CTF experience, and I really, really enjoyed it the past 2 years.
Yeah, and that's kind of when I realized that my skills to write software were also very useful in reverse engineering them.
Yeah. So you started kind of getting interested in cars in a professional level, but you were also doing that for fun, like reverse engineering car stuff, right? And I think one of the articles in your blog, the earlier one, was some Audi A8 related stuff. Can you tell us a little bit about that one?
Sure. Yeah. So this was a Comma, and we had this hackathon where everyone was like, we should do a cool project. And it's like with two of my colleagues, we also were looking for a project. So what this Audi had, most cars, the different modules in a car communicate over CAN. But then the Germans came up with FlexRay, which is this newer high-speed bus that has some stricter timings. And then people in our community said that this bus couldn't be hacked. Well, and
that sounds like a challenge.
Yeah, if somebody says it can be done, and we thought about it before, and it's like we told them, it's like, yeah, this is how you should do it. This is probably it's going to work. They're like, no, it's never going to work. Well, and then we had to show them.
Tell us more about all its weaknesses and probably, kind of how you viewed. I don't know. Tell us more about what the bus architecture is like.
Yeah,
so we can understand, understand why they thought it was unbreakable.
I mean, maybe I should just start with how CAN works and how most other cars work, and I guess also how openpilot deals with this.
Yeah.
But yeah, most cars have different modules that control different parts of the car. Like the most important part, I guess, is the engine control.
Yeah.
But there's also the power steering. Most power steering is electronic nowadays, mostly to save fuel. And there's like a camera on your windshield that detects lane lines. And there's like the immobilizer. There's like blind spots. And there's all these modules that somehow have to exchange information with each other. So they're all in this CAN bus or multiple CAN buses. And on this bus, they can exchange messages, like small 8-byte messages with each other.
So this is, I don't want to call it legacy, but this is the one that's been going on for a few decades, right? I guess the CAN bus.
Yeah, and I would say most cars produced today still use this.
Okay.
Definitely, I think all of the God, what the heck is that car's name that I hate? The Tesla.
Oh no!
I mean, I hate other cars, but
Tesla probably does their own thing, I'm sure.
Yeah, but Tesla has always had like kind of like an indoctrination where they like anticipate that new people are going to break the CAN bus or break the car via the CAN bus.
But Tesla still uses CAN to communicate between the modules mostly. Yeah. I mean, they use some Ethernet as well.
Yeah, I've heard of Ethernet, and so well on cars. Of course, I've heard of Ethernet. So, what's the difference between CAN and FlexRay? What? Yeah. I guess what are the improvements or changes?
Yeah.
So on CAN, all these messages are kind of slow. It's like so it's like 500 kilobit, so which is pretty slow. And usually what happens on these cars, like these cars are all drive by wire, and then for the lane keeping assist, there's a camera on the windshield that tells the car how to turn the steering wheel. So what you can do is you can just take 2 CAN transceivers, and then you can just sit between the camera and the rest of the car. And then if you see a message coming from the camera, you can just look at it, see if you want to change it or not, and then you forward it to the rest of the car.
So a man in the middle style attack.
Yeah, I can do like a man in the middle attack. And the timing constraints are super lax. So the car is very happy with this, like the fact that you can just change this message on the fly. But yeah, with FlexRay, so there's a few successors to CAN. There's like Automotive Ethernet, there's CAN-FD, and there's also FlexRay. And FlexRay is on this schedule where there's like every module in the car gets its own time slot where it can broadcast something. And then if you try to do this man in the middle attack, you can't just wait till the message is received and then broadcast it again, because by then you've missed your time slot, and the rest of the car will get very upset.
I see.
How'd you get around it?
Yeah, that's the next question.
So yeah, if you just buy a microcontroller with like a FlexRay PHY on it, then yeah, that will just receive the whole message, and then like by the time you can change it and send it out, it's too late. So what we did is we took an FPGA and we built our own FlexRay PHY that we just put between them that could operate on the bit level. So we just waited for the message to come in, and then the address kind of is at the start of the message. So it was like, this is an interesting message. Now there's data coming. We would just count the bits, and then it's like, this bit we need to flip, and then we would flip it on the fly, and then we get sent to the rest of the car. And then you have to make sure at the end is the checksum. So you have to like know which bits you actually changed, recompute the checksum, and also mess with that on the fly. So basically, we could change the messages without changing the timing.
Oh, that's pretty cool. So yeah, so it's operating on a bit stream instead of on a packet basis.
Yeah, which you can only basically do in an FPGA. Like this runs at like 10 megabits. So if you use like an STM or something, that's kind of hard to do.
That's really cool. And so you, for this Audi project, you looked at the FlexRay bus, I guess. You developed this kind of interposer, I guess. And do you just start rewriting messages to just for fun, like to do what? I guess
Yeah, I mean, we mostly wanted to prove that this was possible. So we just overrode the steering message that the camera uses to steer the car, so we could drive the car with a joystick. That was kind of the plan.
Oh wow, yeah.
Yeah, I mean, yeah, it makes for a very impressive demo if you can just sit in the passenger seat with a joystick, and then you can actually move the steering wheel.
Maybe I feel like maybe I'm missing something. So instead of like you figured out how to change things on the fly, but you couldn't necessarily decode the message itself because you'd basically miss your time slot. But with the joystick, you're just injecting new messages then? Or
well, so you can't just wait till the whole message is decoded, like till the whole message comes in. So it's basically you have to look at the address and then know it's like, oh, now the rest of my steering message is coming.
Okay.
And then you have to know it's like, okay, so the steering signal is like bit 60 in this message. And then you count the bits and it's like bit 60. Now it's my time. And you start messing with the message.
Okay. So you're swapping out as the stream is coming through and retransmitting it so you don't miss the timing. Okay. Thanks for clarifying that.
Well, you have to, of course, figure out which part of the message is relevant.
Right.
Which is interesting. So yeah, so I mean, this was like a weekend project, it's a little bit more because we spent another weekend to actually design this FPGA board, so we were ready. So on Friday, I was in San Diego at the time, so went to LA to pick up this Audi A4 that we rented to test this on.
Yeah, you don't want to do it on the good car.
well, I mean, these cars are really hard to find. Like the Toyotas will come with the driver assistance packages by default, or like a safety package, but of course, Audi makes you pay for the safety. So yeah, we had to find a car with the right package. So this person on Turo really said this car is going to have adaptive cruise control and lane keep, but we went to LA and of course it didn't. So we were like, okay, we brought back the car. We were in some McDonald's in LA, and then we found this Q8. It was like this massive Audi that had the right packages. So.
Okay, so just follow. You said you conducted business at a McDonald's. in LA.
Yeah, and then I called this guy and it's like, can we pick it up? He's like, yeah, sure, but I'm not home right now. Like, but you can pick it up in Compton. And it's like, and I didn't know.
You only know what the Hollywood version of Compton is.
No, I knew of the movie, but I haven't even seen it. So I was like, okay, sure, well, yeah, Compton, okay, fine. But yeah, we went to Compton to pick up this Audi Q8,
Okay.
and then we drove it back to San Diego.
Okay.
And we started hacking on it.
Okay. Did you get fries at the McDonald's? Or you just said,
I remember, I think at Tour Camp, they did get a bunch of rental cars for the car hacking village. And so it seems to be pretty common to get rental cars to connect to the OBD2 port and start playing with.
I feel like I can never rent a car again.
I mean, don't try this at home. Yes, but
be aware of liabilities that you may incur for hacking your rental car.
It's probably in the fine print somewhere, but
it probably is. But when you return the car, nobody's looking on the inside. Mostly,
well, nobody's gonna check the computer, right?
They're not gonna check that. They're just gonna check: is there vomit? Does it smell like smoke? And are there dings on the car? That's, I think, mostly what. I guess is why it's ideal.
We didn't change any of the stuff in the computers. Yeah. We just changed some bits, I guess. But yeah, so we got the car, we got our interceptor running in like passive mode, and we started looking at these messages. So it's like these big FlexRay packets.
Yeah, how big are the? Just to give context, how big are the packages? Or sorry, the packets.
So it's been a while, but I think there were 256 bytes instead of the standard 8, and the bus runs at like 10 megabits. You have to give much more bandwidth, basically.
Yeah.
So we were like completely ready to like reverse engineer this massive data stream. It's like, surely they must have changed to FlexRay for some reason, right? Well, and then we started looking at the packets, and it's like this big packets, but it's filled with zeros. And then all the way at the end, there's like this small 8-byte message. It's like, what is this message?
This is the CAN bus.
It's just, it's like CAN over FlexRay.
Yeah. And then we started looking at it. It's like, and then we already know what the messages looks like on Volkswagen, on like a Golf.
Yeah.
And it was like, wait, but this is just a message from the Golf, and they stuck this in this big packet.
Yep. Well, I was gonna say, like, I think A3 is basically the equivalent of a VW Passat. A4 is like kind of like your next step up. It didn't surprise me that they would reuse.
I mean, yeah, it's all the same group, of course. Yeah. So, I mean, the checksum was a little different. Like the CRC was XORed with a different value, so we had to figure that out. But besides that, the message layout was exactly the same as your basic VW Golf, which was
nice. Is there like an open database of some of these things in the community? What these messages?
These files called DBC files, which are kind of like the representation of all the bits and bytes on the CAN bus and what they mean. So comma.ai runs this project called OpenDBC, which contains all these reverse engineered DBC files.
Oh, cool.
But they're not open. They're not like the manufacturer one.
Oh yeah, I figured the manufacturer would never. But I guess OpenDBC is what I was curious if it existed, and I guess it does, which is
cool. So there's most newer Hondas, Toyotas, VW, they're all in there.
Sweet. And just last question on this particular project. So this sits in the middle. Do you have to disconnect somewhere and put this in the middle, or does it kind of hang out on the bus?
No, you have to actually intercept. You have to actually cut open the bus and then put your thing in between. So for most cars, you can do this at the camera, but this Audi has like mostly all the intelligence is at the camera. It's just a camera, but it's also a microcontroller there. Mm-hmm. But this Audi has like this big computer somewhere under a seat. So we actually intercepted the bus between the power steering and the rest of the car.
Okay. Oh, cool. Oh, because I mean, that's where you wanted it to go in the end anyway, right? So
yeah, usually it's just not the most convenient place because the power steering is like somewhere under the hood and the camera is very accessible from the cabin. Mm-hmm. But yeah, if you have to, you do it at the power steering.
Cool. All right. So I guess the original reason, or I guess how I found out about your work, was a recent post on hacking the VW Golf, the power steering ECU. And this is like a 4-part blog series you have that's really, really neat. So I guess I want more people to know about it. So can you tell us a little bit about that project?
Yes. Let me tell you some more about that. So this basically started. So I had a new colleague join us in our office in Rotterdam, comma, and he got this 2010 VW Golf, which apparently you can make compatible with openpilot, even though it's pretty old.
Wow.
And then, but we found out that this power steering motor only accepts like certain commands above a certain speed, and most annoyingly, after 6 minutes, it just suddenly stops working.
Oh wow.
I mean, it's not really a good reason that it should stop after 6 minutes. I mean, later it turned out these were probably just the default configuration that VW never bothered to change. But yeah, I wanted to find a way around this minimum speed and this 6 minute timeout. So that's kind of how I started looking at it.
The minimum speed makes sense to me from cruise control. Like older cars, you couldn't do cruise control below certain speeds and stuff. I don't know if that like it's anything related, but how'd you get started? Like, okay, so your friend has a car, but he probably doesn't want you to take it apart to figure out how it works.
Yeah, so what I usually do is, I mean, you can just connect like one of these dongles, and you can read like the part number and the firmware number from the power steering or like all modules in your car. And then with this part number, you can go on like eBay or some other secondhand parts website. There's many crashed cars that you can get parts from, and then you just buy one, you put it on your desk, and you connect power to it, and you connect the canvas to it, and you can start talking to it.
What kind of power are we talking about here? Is it going to require 12 volt plus or?
Yeah, it's usually just 12 volts. And
Okay.
sometimes you have like supply with ignition. Sometimes it wakes up based on CAN data.
Okay.
I mean, these power steering motors can draw like huge amount of current, but
Yeah.
if you don't connect anything to it, you can just use like a simple wall wart plug and it will work.
Oh wow. Yeah, I guess it's probably not as bad as the starter though, right?
Oh yeah, that's like hundreds of amps. So.
But still, yeah, I guess when you think about the amount of power that's taken up, it kind of makes sense. And you say you power it up, and then you start talking to it, and it's just CAN bus, right? I guess that's
yeah. This car has CAN bus already. Yeah, so yeah, you need to look up the connections, but usually these schematics are kind of open. There's like all the right to repair stuff. So you can usually pay like a small fee to your car manufacturer, like $10 a day or something, and you can look at all the schematics, which is very useful. So you can just look at what the pinout is. I mean, you can also measure it, but it's really nice to have all these schematics.
Is this a thing in Europe, or is this?
No, it's mostly a US thing.
Oh,
So yeah, it's like usually it's called like tech info. So if you Google like your brand tech info, you'll find all the portals.
Oh wow, I did not know this. Like I've back when I had a car, I had like downloaded bootleg manuals and stuff. I didn't know I could get it legitimately.
Yeah, usually I was very surprised by this as well, that it was so easy to find all these things. Like usually they even have the software, and like there's like a standard for all these manufacturer software to talk to over CAN. So you can get this like $200 dongle, and you can even use all the software.
Wow.
And then I started talking to it over CAN, and there's like this standard diagnostics protocol called UDS, which has some standard things to get like firmware version, but a lot of more interesting stuff. So I tried that first, but it didn't work. So what I did then is I took this VW specific dongle, which has like an Android app, and I connected that to the power steering on my desk. I got a little, and I started that up. The app got a little bit upset because the rest of the car was gone. But after some convincing, it started talking to the power steering, to the EPS, and I could see what it was sending. And after like some reverse engineering, some Googling of the messages I saw, I found this custom protocol that only VW uses on these older cars. So I implemented that in Python, and then I basically could talk diagnostics with this module.
Nice.
And so when you say you implement in Python, what's your gateway to CAN?
Yeah.
So comma.ai sells this device called a Panda, which is this USB to CAN dongle. Basically has 3 CAN buses, some other stuff, and a nice Python library. So yeah, you can just do panda.can send, and you give it a message, and it will send it.
Oh, that's pretty cool. I love hearing about tools. So
yeah,
this is great.
Yeah, not a lot of people know about it, but yeah, it's super nice. It also has a We have like the white Panda, the original one, also has an ESP on board, which you can program yourself. So there's an STM and an ESP, and you can talk to it over USB. So it's very configurable.
Mm-hmm. And it comes in different colors.
Yeah, the OG one is white, which is the ESP and STM. And then later we started using it more for openpilot stuff. So we added like a GPS, which is less relevant for car hacking.
Very cool.
But yeah, my ultimate goal really was to obtain the firmware that was running on this thing.
Okay.
So usually I try software first, and if that doesn't work, I try to resort to hardware. So yeah, I tried I got this diagnostics working, and then this diagnostics protocol has this nice thing called like read memory. So sometimes it works, sometimes it doesn't. Sometimes it's behind like a security algorithm you have to go through first. Sometimes it only lets you read certain addresses. But yeah, in this case, it was behind the security. So I kind of gave up and just like started looking at hardware. So I opened this thing up, and I was ready to connect like JTAG to it or something. But yeah, then it turned out to be this like weird bare die construction. I don't know if you've seen the pictures, but yeah, it's like this wire. It's like it's like dies on some ceramic substrate, wire bonded. So yeah, there's no way I was gonna get a JTAG to that. Unless you have like one of those needle machines, like there's no way.
Yeah. Unless you're exceedingly nearsighted.
Yeah, I'm looking at the picture here. This is crazy. Like, yeah, there's several dies on one of these ceramic substrates with a bunch of components in between and just wire bonded all over.
Yeah, and it's not like the thing has a part number which you can look up. So it's like I didn't even know what kind of CPU architecture it was. Like, I mean, I know the architecture now, but I still don't know what the part is.
What's the architecture?
It's a V850. It's like this automotive
part.
Is this what the Tricore was, or is this something else?
No, automotive is usually V850, Tricore, or PowerPC.
Okay.
That's where all the PowerPCs went.
They used to have multiple cores running in lockstep for these very safety critical devices.
I was just really surprised you used the word PowerPC. That's where they all went. They just kind of fell off the face of the earth. I thought like sometime in 2000.
Yeah, no, in automotive they're still very common. I guess on Mars and in automotive.
Yeah, space stuff too.
Well, they started the design probably at that time, so.
I mean, they're still kind of common. I still see them quite a bit. But yeah, so I guess hardware was out of the question, so I had to get back to software.
Mm-hmm.
And then I tried to get this security algorithm thing working. So I took the dongle again, and the dongle has like a nice login button. So I pressed login, and then it nicely suggests a password. So I tried that, and it worked. But it turned out there were more security modes. There's like less secure modes and higher secure modes. So the mode that the dongle put me in didn't allow me to read memory still. But yeah, it allowed me to observe how the login procedure works. So how these things usually work is that the module sends you like a seed, which is like sometimes 2 bytes, 4 bytes, sometimes more. And then you perform some cryptographic operation on it, sometimes some XOR, sometimes something more real. And then you have a key, you send it back, and then the device will tell you if the key is correct and you're logged in. And usually there's ways, again, like to prevent you from brute forcing. Like if the device is just booted, sometimes it won't give you the seed yet. You have to wait like 30 seconds before you can get your first seed. So you can't just like turn it off after your failed attempt, turn it on, and then immediately try again. And also there's ways sometimes if you do like 3 wrong attempts for the key, you're also locked out.
Forever or for just a time?
Sometimes until you turn it off and then on. But in this VW case, I actually write something to non-volatile storage, and then you have to wait like 10 minutes before you can try again, which is quite long.
Yeah, so if you turn it off, it stops counting the 10 minutes, basically?
Yeah. Yes.
Oh, smart.
Yes. So yeah, the first time I got locked out, I was like worried. It's like, why can't I try again? I waited, I rebooted it, and then I had to wait 10 minutes. It's like, oh shit, do I need to put this in a car? But yeah, then I read this thing where in what they do is like if you have a wrong guess, then they increase the counter, and then if it hits 3, it locks you out. But if you log in again with the correct password, your count is reset to 0. And I had one of the passwords that was like a lower security mode.
Yeah.
but that was fine. So what I could do is I could log in with the known password, and I could try logging in into the more secure mode. And it's like, okay, your password is wrong. But then I would just log in again with the known password, and then my count was reset to 0, so I could just try infinitely many times. And the search space was 16 bits, so this takes like 5 hours to brute force.
This is dumb.
But lucky that it,
yeah.
Yeah, and I see you have a Python script here for the brute forcing.
Yeah. I mean, so I was super happy that I brute forced the passwords, and it's like, oh yes, now I can try this read memory. And then it turned out it only let me read the first 1,000 bytes, which is very sad. So this is all for nothing, basically.
So curiously, are the low level passwords are they all the same, and then the high security one is unique, or?
What, oh, you mean unique per car or
per car?
No,
or
no,
is it per line or
they're
per
just
family?
I guess they're the same for all firmware versions, so they're the same between all cars. They're just different passwords for each mode.
Mm-hmm. Thanks for clarifying.
So then you got the first kilobyte, I guess, right?
Yeah, and it was like some kilobyte of the non-volatile storage, so it wasn't even the flash I was interested in.
Oh.
You're like, success. Look at what you got.
I mean, you got something.
Yeah, I got something, so that's nice. I mean, I was happy at brute force. So I kind of like I already used 2 out of 3 of the things you can try. So you can try like JTAG, which didn't work. You can try the diagnostic stuff, which didn't work. And then I started looking for update files. So usually these ECUs can be updated. Like sometimes they need to release a bug fix, and then they have to ship this to all the mechanics all over the world. So these files are basically public. But it's not very common that power steering motors have bugs. So usually there's no update files for them. But in this case, there was one. I'm not really sure if it was a bug or if they used the same module for different cars, and the only thing that was different was the firmware. But yeah, there's a couple different firmwares out there, and there were update files, which are nice.
Is it considered a security flaw that the passwords are so heavily tied to the firmware, and the firmwares may be updated a lot, so the transferring the firmware and the new updated passwords seems like a liability? But
I mean, it's really a good question. We can touch on this later. It's like, what really is a security issue here? Like you need physical access to these modules. Like
yeah. Well, let's delay on that one. Let's see. So so you got those first 1024 bytes.
Yeah, so that didn't work. So I already used two methods, and then the third one is the update file. So I started looking for this update file, found this weird container format. I was like wondering, it's like, does this contain code? Like the file was like 300 kilobytes large, so the file size was kind of right. It's like, this could be the application. So then you can run like strings on it. It's like, okay, nothing. This is garbage.
So was it encoded though? Somehow, maybe?
Yeah, so what I did next, I ran Binwalk, which can make this entropy graph. And the entropy is very useful when you're looking at these unknown formats. And then you see like the entropy is like around 0.8. So if the entropy is like 1, that means it's usually compressed or encrypted, which is annoying. Or if it's very low, then there's nothing in there. But if it's like 0.8, that's usually like code. And in this case, I got lucky, and it was actually 0.8. But still, there are no strings, readable strings. So this probably means it's like a simple, small XOR cipher. And then it turned out it was just everything was XORed with hex FF. And then I XORed it with hex FF, and then suddenly all the strings popped up. And
I used that technique of back in the 90s. I don't consider myself a security expert.
I mean, in the meantime, VW has started using a little bit more secure update containers. But yeah, I mean, at some point, people figure them out. Like their software that they ship to all the mechanics need to parse them, or the ECUs need to parse them. So if you figure out one of those, then you can just usually figure out what you need.
Do all of them. So is there like an age of like a vintage, like a definite like era where like it was easier and now it's harder? Is there kind of like...
I'm not a super deep VW expert, but I would say after like this is like 2010, this was already kind of the late era of these older files.
Yeah.
After
Yeah.
2010, it was probably the newer stuff. It also seems that they care a lot more about like the engine control module, about all the tuners and stuff, and all these like power steering stuff, and like it's more of like a little bit more behind.
Probably changes less too, right? Like the power steering probably doesn't change nearly as much as an engine control unit between cars and models.
I mean, yeah, and VW is very good at reusing parts. Like this power steering motor is like used across like a whole lineup. But I've seen like for Toyotas, they use a different one for every model. I've even seen like on some RAV4s where they switch the power steering motor like mid-generation.
Oh wow, supply chain.
Yeah.
Probably more nowadays.
Yeah.
So now you have I don't want to call it plain text, but a non-XORed firmware or update file, I guess.
File. So yeah, I knew the firmware was in there, so I started doing some more research, and then I found this tool that can parse this file actually and tell you like the offsets and like where this thing actually gets flashed. So yeah, I was able to extract it from this update file, and then I needed to figure out what architecture it was. So there's this tool from the Airbus labs called CPU Rec, which is this big dictionary of like function signatures, I guess, or like opcode.
Is that CPU like rec like a car or rec like a...
No, like recognize or REC.
Okay.
Yeah, it's linked in the blog post here.
Yeah. So I ran that, and it told me it was V850, which is kind of what I expected. Like it's either tri-core V850 or PowerPC.
That's pretty cool. And so you said this was this programming file had the locations and stuff. So it's kind of like an ELF file normally, where it's not just the whole raw image, but it tells you like, okay, the next so many bytes are going to go to this address, and the next so many bytes.
Yes. So there was like this block that started like address A000, and then after that everything was in the update file. Cool. So what this told me too is that there was probably some bootloader on the device that was before the update file that I didn't have, that is used to actually flash this. So they jump to the bootloader, and then they can write the application firmware.
Cool.
So yeah, the next step is I load it into Ghidra, and then it's reverse engineering time.
And of course, Ghidra supports this V850.
Yeah, I mean, that's a nice thing about Ghidra, that users can add their own architecture. You just have to write your SLA, and then.
But this was already there, I assume.
Yeah, so there's this is a community supported one. I also it was first in someone else's repo where I added support for the floating point instructions for some other project I was working on. But by the time I did this VW project, it was already upstreamed in Ghidra, so it was super nice.
That's pretty cool. When you do these contributions for Ghidra, is this all in Java or is this C++?
Well, this is SLA, so yeah, it's their they have like this DSL where you can kind of specify what an instruction looks like. So you said like which bits mean like this is an AND instruction, and it works on these registers. And it's like this is how you decode it. And the nice thing is you also give like a symbolic representation of the instruction, which they call P code, and that basically makes the decompiler work.
Oh, nice.
So once you write a SLA for this new architecture, then you get Ghidra to start working, but the decompiler also starts working.
Oh, wow.
See, at this point, I'm wondering like what processors are there left that Ghidra doesn't have? It can't work on.
I think
that's what
until recently it was like RISC-V. They added
It's probably just because it was too new.
Yeah.
No, I think they mostly support basically everything now. It's like maybe some very obscure old Bosch stuff or something. But
yeah, I guess if the documentation isn't out there, then it's a lot harder to write these SLA or whatever.
Yeah, but yeah, if you have like an architecture manual with all the bitmap, all the opcodes, it maybe takes you like a few weekends to write a SLA, and then you have support.
Yeah, it depends on the instruction set. Yeah.
And
oh yeah, I wouldn't want to write x86. That would be a nightmare. But
legacy you could probably deal with, but you know the expansions beyond that, MIPS, I would not want to have to do that. It's so long, like so many versions.
Have you used Ghidra a lot before, or how did you start using that?
Yeah, I started using around the time when it came out. That was kind of the time when I started doing reversing. So that was pretty nice.
Okay.
So yeah, I did some like Linux stuff, ELF stuff, and then
Are you using it bare?
What do you mean bare?
Are you using it with like not in a virtual machine. You're just using it right on your.
Yeah,
You're
yeah.
like trusting right away.
Living on the edge. I mean, these embedded firmware files, right? You can't even run them. So
This was before Log4j.
yeah, it was actually if you loaded like this elf file with like this string and the header in like some section, then yeah, you got log4j. I'm pretty sure that when this firmware was written in like 2006 or something, that they didn't think of Ghidra.
Yeah.
Yeah.
Oh, that would be long. That would be a long planned project. All right. So now you're on Ghidra, and I guess as far as I'm concerned, now you know exactly how this works.
Boom, boom, boom.
Yeah, and
With
you
enough
have
time.
many long nights in Ghidra to figure it all out. Like you start out with this binary. It's just this flat binary. It's like you don't even know what's code and what is data.
Oh, wow.
So yeah, you start guessing at the layouts. Like you see, there's like a bunch of code, and then the data comes after. Depends a little bit on the architecture. Like some architectures, you can like press decode code everywhere, and everything looks like valid code. But sometimes you have like these architecture where it's very clear that things are not code.
So it's not like ARM, because I know in ARM you have the really nice vector table that points you to the reset vector, and then you could just start going from there. But
yes, yeah, you see, you can but usually you can do that, and you find some of the code, but some of the like sometimes they implement like these threads where the functions are then referenced from like a table. So there's nothing jumping to it, so you have to like do some more work to find them.
Okay.
And well, in this case, I also didn't know I knew that was V850, but I didn't know what the microcontroller was, so I couldn't just download the data sheets.
And you still don't know what it is, right?
I still don't know. No, if somebody knows, that would be great.
That's really cool. But you still were able to figure out what you needed to.
So I'm kind of curious, during your analysis in Ghidra, did any of the Binwalk information that you had previously, was that applied, or was that even relevant at this point?
Well, so the entropy graph, I mean, I still use the entropy for this kind of stuff, but yeah, Ghidra has its own in the sidebar. You can like show the entropy. So that was still useful. So you can see like, oh, this is code, and there's like a little bit of nothing. And then like there's a new section of high entropy. Well, that's probably the data.
Yeah.
But yeah, usually you start with the data sheet for the chip, and you like look up the memory map, and you start adding the memory map to Ghidra. You add the registers, and then you add the CAN registers, you label those, and you look, okay, where are my cross references to my CAN registers? Like, surely like it's communicating over CAN. This is a great place to start. But yeah, if you don't know where the CAN registers are, then so yeah, what I usually do then is a trick from my colleague Greg. Is like you have these diagnostics protocols, and these have error codes, and they're like certain error codes for like login field or something. So what I do in Ghidra, you can just decompile every function into one big C file, and then go into VS Code, open the C file, and you just Control F for like return 35, which is like this certain error code, and you just look at all the functions that return like this error, and usually that gets you very far in finding the diagnostics handlers.
Oh, okay, interesting.
And then from the diagnostics handlers, you can usually find how it communicates over CAN, and you can find the other, like it's parsing messages from, say, like the wheel speed sensors that tells you what speed the car is driving. So you find at some point you find the code that's parsing those messages, and then usually the speeds will be written in some global variable. You start looking at the references to those, and then at some point you hit like the check of the minimum speed I wanted to patch out.
Yeah, I mean, you gave us quite the list of like tools that you're using on that. Have you used them pretty consistently across all of your car hacking tools or car hacking projects?
I mean, yeah, I use the Panda a lot to communicate, and there's like all these abstraction layers for all the diagnostics protocols. And then Binwalk and Ghidra are very useful. So yeah, and then basically I did all the reverse engineering, and I identified what I needed to change. But then there's the questions like, how do I actually make these changes? So I identified this area in some calibration file where all this, basically I didn't need to change the code. I just needed to change this settings file. It's like this .ini file, which had all the like minimum speed is this, and like the timeout of 6 minutes is this, and I wanted to change those.
Okay, so you've totally understood all of the firmware that's in there. Now you're making changes. Tell us how you pack all that back up and then roll out your changes and then test them.
So yeah, I was talking before how I only had the application firmware and there was probably some bootloader before.
Yeah.
So yeah, the question is like, how do I figure out how that bootloader works if I don't even have the code for it?
Yeah.
And my read memory thing also didn't work. So I needed to find a way to dump this bootloader off the device that I had on my desk.
Mm-hmm.
So I started looking for more code that was parsing CAN messages, basically looking for an arbitrary memory read, looking through all the diagnostics code. At some point, I found like this handler, and there's this protocol called CAN Calibration protocol that they use when like designing or tuning these ECUs. Yeah, so I found this protocol implemented, and that has an arbitrary memory read and write. And it turned out it was not secured; it was just open.
Oh, nice.
So I could just send the right message to it, and
Alvaro, that's not nice.
and it would just give me them. I could just peek and poke at memory, which is
That's
great for
extremely
a
nice.
hacker.
I consider that kind of disturbing. I mean, it's great for moving the project forward, but it's a
I mean,
little
it is very surprising how at some point I realized that these protocols exist, and once you know what to look for, like you just broadcast, like you send this connect command to all
Yeah.
possible addresses, and it's like even on newer Hyundais, like 2020 models, like you just get a response.
Nice.
Okay, so I also don't want a Hyundai. Okay.
Yeah.
I think you need a car with a carbureted engine and no electronics, right? Like that's the only.
Yeah, I think there's no way around this. Like,
Yeah.
so yeah, I found this arbitrary memory read write, and then I used that to dump the bootloader.
Oh, the bootloader
Cool.
itself. Okay, so
Yeah.
because you already had the image, I figure, or like some image.
Some update file, and then of course I checked that the thing I was running on my desk was the same as the update file. It was like slightly different, but
Mm-hmm.
And this is so you could use the bootloader to update it, right? Because you didn't have the update tool.
yes, there's like all the you can like find them, but it's like Windows only. I tried to install them, was just too much of a hassle.
Wait, so you're saying that installing Windows was what was holding you up? None of the other stuff.
It's easier to reverse engineer.
I do have a nice Windows VM, but yeah, this is old stuff. And none of these tools like connected properly to it when it was not. I don't know if it was because it was not in a car or because like there were crappy like cracked version of this tool, but.
And tell us, where do you get the cracked version?
Well, it comes on the CD when you buy like the clone dongle from China. It comes
oh, that's nice.
Also, not nice.
It comes in a CD. So
that's the thing that always kills me about things from China. There's a CD, but you're like, should I put this in my machine?
Yeah. Where does this go?
But yeah, I had the bootloader, so I put that in my GitHub project. I loaded that over all the zeros I put for the bootloader, and then. I mean, these bootloaders also follow like a standardized diagnostics procedure. So you log in and then you ask for an erase, and then you ask for a transfer, and you start transferring the bytes, and then you compute the checksum. And then if the checksum is correct, then it basically marks the application as valid, so you can boot into it again. But yeah, they all have like very minor differences. But yeah, once you find the handler, you can see all these states and then see what the quirks are for this specific ECU.
So when you were packing it all back up, testing, I guess, like how much could you really test because you don't have the full car to see?
Yeah, I mean, most of the things I checked is like this. There's like these few bytes in this calibration area that. So car manufacturers really like to call don't like to call things updates, so they call them calibrations. People don't like their cars changing, but they like them being calibrated.
It's marketing, damn.
Calibration, not an update, damn it.
Yeah, so you find these values in the calibration, and then you can see where they're used. And then I made sure that they were only used in the one place that I wanted to change them.
Okay.
So it's kind of the verification that you do.
Mm-hmm.
Well, yeah, and then you have to flash it on the actual car. And then the first time you do it, you forget to change one of the checksums. So then it boots, but it goes into limp mode, so there's no power steering. It's these dash lights, and it's like, did I break his car? Like flashed it back. Okay, it was fine. It was back to normal. And it's like, okay, I need to look for this checksum, and then I found the checksum. I fixed it, and then it worked.
Yeah.
And basically, this remove the limits of the 6-minute timeout and then the low speed steering, right?
Yes.
Mm-hmm. Mm-hmm.
That's pretty cool, and I guess it works.
And that works, yeah.
Yes, that it sounds it's a lot of steps. So, how much time did it take you to go from the start to the end of this, though?
It's really hard to tell. It's like, lots of weekends, evenings.
Yeah, so it wasn't like
It's probably like a couple weeks. If I would spend full time, it's probably like 3 weeks full time or something.
Wow.
Okay. It was not insignificant.
No.
No, it didn't sound. There's a lot of steps.
We're gonna link to the blog post, which go into a lot more detail for those who want to dive into even more
With pictures.
Yeah. Oh yeah,
Crucial.
you have to see the pictures of the dies
Yeah.
wire bonded. And I was like, this is inside of a car, I guess.
So yeah, I did all this stuff, and I was like thinking, like, yeah, when I started car hacking, like I didn't know all these tricks. They really took me quite a while to figure out. And there's like the car hacking handbook, but besides, there's not really that much out there. So it's like, yeah, maybe like for me, this isn't really rocket science anymore. It's just like chaining all these things together. But
Mhm.
I thought it was really useful to just write it all down so people could read it, and then
Mhm.
people seem to like it. Like the thing went viral on Twitter. So
Yeah.
I think the thing that I appreciate out of this is that there's not that many specialized tools. At least that's what I'm hearing from you. Is that yes, there's some software tools that are specialized, but in terms of new hardware dongles and bits that you would need, not very much. And then you're utilizing a lot of the tools that we already use for RE to begin with. So I thought that
yeah,
was nice.
yeah, it's just
Investment
like
is low.
tricks, like knowing the diagnostics standards that are out there that they all
Yeah.
use is very useful to know.
So it also seemed like what was really important through your exploration, particularly at the end. It seems like a best practice is make sure that you know how to update and undo and go back to whatever you had before.
Revert.
Yes.
What else? What else is a best practice? Should you do this on the car that you use for your daily transportation?
You should definitely buy another module, like on the module you're
eBay
working
or
on.
something? Yeah.
Maybe more than one is very useful.
Mm-hmm.
I mean, I didn't brick anything myself, but I've heard stories of colleagues to work on this EPS and then made some code patches, which is always tricky because if you mess that up, then then it just doesn't boot anymore. You can't go in the bootloader. So you had to flash it back over JTAG. And now the clock runs at like a quarter of the speed. And we couldn't really figure out why. We thought it was broken first, and then we connected the scope to it. It's like, wait, this still can, but it's just like 4 times as slow. So now we have this desk experimentation module that runs at a quarter of the clock speed. This is very annoying because if you normally when you get a seed, you need to wait the 30 seconds for it to boot. But yeah, that's now like 2 minutes.
Yeah. In terms of effort, it seems like there's a lot of steps, but there's nothing impossible, is what I'm hearing from you. Is that true? How much effort do you
on
feel
these older modules, like they don't do any real cryptography. Like the newer stuff, like the firmware is signed, you like really need to find a real exploit around this.
Mm-hmm.
These older things, it's mostly just reading the specs, knowing which standards are out there, and then chaining it all together.
Mm-hmm. Mm-hmm.
And I guess changing topic a little bit, we've mentioned many times openpilot. Can you tell us a little bit about what that is?
Yeah, openpilot is this software, it's an open source project on GitHub that you can run on like a piece of hardware, and you connect it to your car, and it basically is like a level 2 driver assistance system. So it's kind of like Tesla Autopilot in the early days when it was just lane keep and adaptive cruise control.
Mm-hmm.
But yeah, it's open source, so you can just hack on it. It supports like more than 150 different cars.
Wow.
And it's I would say it's really good. I use it every day, and I work on it.
That's pretty cool. And how much of the kind of you support 150 cars? Is that a lot? A lot of that has that been through reverse engineering, or are there any open standards for if you have a system like this is how you should speak to the car?
No, this is all reverse engineered. I mean, luckily not all 150 cars are different. They're like once you understand the brand, are mostly the same. But with some small quirks. But
for people who wonder what practical applications reverse engineering has, like we keep saying lots of them, but we're literally enabling 150 some cars to kind of be interface with, which is really cool.
Yeah, and these cars, so you need a car that already came with adaptive cruise control and lane keep. So it basically has these drive-by-wire capabilities. But yeah, these lane keep assist systems from the manufacturer just really suck. And then openpilot's a real upgrade. Like you can read, especially on like commutes or long road trips, like it just drive for hours without disengagements.
Yeah, so there's a couple questions I have backed up here now. So it's like, okay, one, it sounds like for, maybe somebody has a car, an older car, and they want to retrofit this onto there. How easy is that to be done? And if it's not listed on one of the current 150 cars that are supported, what are the steps for them to basically, I guess, do a port?
Well, basically how it works is you all these cars have a camera on the windshield that usually does the lane keep assist.
Yeah.
So you need to start by finding the right connector on that this camera uses. And then you plug that into the Panda, which is the STM, and then you connect that with like one of our dev kits usually, which has a nice, runs Linux, has a nice Snapdragon 845, has the Panda built in, and you stick that to your windshield, has all the cameras, and you stick that to the windshield, and then you put openpilot on it, and then you can start seeing what messages are being sent.
Well, I'm thinking like, what if it's an old enough car where there's not that type of camera on there? So let's say it's like something from like the year 2000.
Well, it wouldn't have drive-by-wire.
Yeah, then you're out of luck. This is usually like 2016 and up, and like some older VWs, because they already put the power steering in place. Like maybe they plan on shipping it, but yeah, in general, it's like 2016 and up with lane keep and adaptive cruise control.
That's pretty cool. Yeah, I've never had a car that new, but I do know people with them.
Yeah, me.
Well, a lot of the cars I've been renting have adaptive cruise control and lane keep assist, and it's mighty nice, I'll say.
Yeah, I'm kind of curious. So I have a Bolt and I have a Subaru Forester, and they both have this capability in there. So I'm just kind of wondering if it's worthwhile for me to like.
Hey, you could have a reverse engineered product on your car,
and then I don't want to get into
some GM supported car. I'm not exactly sure on the Bolt or the specific Subaru, but yeah, there's some Subaru supported. So
yeah, I feel like the Subarus probably get it. Like they're just kind of not ahead of the curve on technology, but it feels like the GM is desperately trying. I mean, I can now finally charge my car at my home without fear of it exploding, supposedly. So, so maybe I should be slow about that.
Yeah, well, one of the questions we had as well is openpilot is, you mentioned, an open source project. Has there been any issues having such a project being open source from manufacturers and whatnot?
Is the transparency a boon or a problem?
I mean, I would say it's great. It's like there would have been no way to support 150 different cars if we didn't have this massive community that can help with porting the cars. Like they just go and try it, and then they submit a PR with the changes needed to port their car.
Oh, that's really cool. I didn't realize like individuals, which makes sense, right? Your car might be supported. You buy a device, plug it in, and then start the reversing process with the tool you're going to use.
Yeah.
And then how the thing works is like there's the Panda, which has this STM32, which runs kind of what we call the safety code, which is of course real time. So that handles all the forwarding of all the messages between the camera and the rest of the car. And that also allows for like every brand, it knows like which messages are steering, which are brake and gas. And then it basically checks like, is this message, can I send this message? Like, am I not sending too much steering, too much brake? It's kind of just like policing the messages that are being sent. Which is important because openpilot is like a level 2 system. So the driver is responsible. And we want to make sure that the driver always has enough time to take over. So the driver needs to be paying attention.
So I can't take a nap. So can't.
No, definitely not. No.
What are the different levels?
I mean, currently there's like, I mean, it's level 2 where the driver has to be paying attention and is responsible. And then there's level 3, which is kind of where the car manufacturer starts taking responsibility, but you can't use it everywhere. It's kind of like kind of vague. It's like you can do this on highways, but then if the car thinks it has to disengage, it can warn the driver. And it's like, how much time do you have to take over? So you still have to be awake. So level 3 is just kind of this weird zone, and then you have like level 4 and 5 where the car really does everything.
Would level 1 be like old school cruise control, I guess?
Yeah, I guess, yeah.
I had level 1.
Yeah, so OPA is level 2. So we use a camera to make sure that the driver is paying attention, and then together with this safety code on this STM32, which ensures that the car can never change direction too quickly, and if you press the brake or the gas, it will block everything. So you can always take over control, and then combined with forcing you to pay attention. This
is more from my curiosity perspective. So that STM32, you have a real-time system. Is that running bare metal, or do you have like an RTOS on there?
No, it's just bare metal. I mean, it is
surprising.
We try to, in general, in OpenPilot, we try to keep the code as simple as possible. So yeah, it's basically just some interrupt handlers on the CAN messages, and like, so it's like, yeah, CAN message coming in, and it checks like, where do I need to forward this? Which bus does this need to go to? Do I need to forward this? And then the packets from OpenPilot come in over USB. They're checked. Am I allowed to send this or not? And it's also like this code is so simple that it can also never generate a CAN message. Like, it can only forward messages from other modules in the car or from OpenPilot, but the Panda can never start sending messages by itself.
Oh, cool.
Can you elaborate a little bit more on some of the safety features to prevent? I guess in my mind, what's worrisome to me is how to manage, I guess, how to prevent accidents in a lot of the cases when it's like, yeah, basically, how do you ensure that you're not, especially when someone's just installed it, just put everything in there and has already set it up, how do you ensure that they don't end up in an accident first time out?
Well, as I said, so we make sure that the driver is paying attention with a camera-based driver monitoring system. So yeah, if you start looking away, then
what if I just draw eyes on my glasses?
At that point, you know you're doing something stupid, right? So it's like we know that the driver is paying attention, and the second part is like making sure that the car never does something so quickly that you can't react. And you should always be able, like, if you grab the wheel, like, it never puts a torque on the wheel that you can't override easily. And if you press one of the pedals, then it instantly disengages, blocks everything. So yeah, basically those two things combined should make sure that you're always in control and we're able to take control fast enough.
Which is what the OEM systems do as well, right? Like, they're just sending steering messages, and then as soon as you have any other input, it'll disengage, as far as I know.
Yeah, sometimes they decouple the steering from the adaptive cruise control, so from the gas and the brakes, which we never allow. We think it's very confusing. It's like you get this mode confusion, like, is my system on or off? Like, have you ever had, like, is my cruise control on or off?
Yeah, mine will disengage if you start mucking around with the accelerator.
But yeah, and then if you let go, then it suddenly starts steering again. I know for us, it's on or off, and you need to be very explicit with a button to turn it on.
Yeah.
Oh, cool. I like buttons.
Push all the buttons.
You just engage your cruise control, and then the system turns on. There's a beep that tells you it's on.
Oh, cool.
Yeah, Alvaro, we have to see each other again, because I could show you the buttons that I have in my car to engage or disengage all the.
Yeah, no, I'm in the Stone Age when it comes to my current vehicle's a bicycle.
You don't have a car.
So, yeah. Cool.
But yeah, so we have this safety model that's enforced by this microcontroller. And the nice thing is, like, we've talked about safety already, and we haven't even talked about OpenPilot and like whatever is running on our Linux side. Just like it doesn't really matter what that does. Like, that is kind of like, I mean, it's called QM. It's like the quality management. It's like the best effort to do the best thing it can. But we already know that whatever it does, it's going to be safe.
Yeah, like so OpenPilot could, say full steer hard right, but then the controller would not allow such a strong or such a fast turn, right?
Yes, yeah, depend. Like if it would really send out the max, then it would be just blocked altogether. Or if it's just around the max torque that is allowed, yeah, then you would still have time to react.
Nice.
That's pretty
I
cool.
really appreciate that. So, what have been some surprising aspects of being in this space for autonomous driving? Anything that surprised you?
I mean, there's definitely some surprises. Like I was mostly surprised, like I guess how well comma is doing with such a small team.
Mhm.
That like I mean our product is actually pretty good. Like everyone who tried it out is like we get very good reviews. Like Consumer Reports tested it,
Wow.
and we ended up on number one. Like they had like the consumer facing one report where they didn't mention us, but then there's also the one where like basically more focused towards the car manufacturers themselves, and they put us in there as well as like, hey, car manufacturers should really pay attention to this. Like the user experience is good, it works very well from a technical level.
That's great to hear.
Yeah, so I mean, that kind of is like the follow on, like what has been the car manufacturer's reaction to exactly that?
I mean, just a lot of silence. It's
Like it's a little surprising. Like, it's like it seems to me like why don't they outsource or license like or something? I don't know. It's a little surprising to me.
I'm sure there's pride somewhere and just NIH
I mean,
syndrome.
self-driving is like the first problem. Like I've thought about this quite a bit. It's like usually when a car manufacturer wants something, they write up a spec. And they're like, oh, I want this module, I want this box that does A, B, C, and like it outputs X, Y, Z.
Okay.
And then they go to like tier twos, and then they build the box according to the spec. And they, especially in the beginning, they thought that self-driving would be like this as well, where they write up a specs like if the lane line is here, then do this. If there's another car here, then do that. But yeah, this is a never-ending thing. Like you can't write a spec for self-driving.
There's just too many variables.
Yeah, this is like where our approach is fundamentally different, but also fundamentally different from other self-driving car companies.
Interesting.
Yeah, I just love that it's able to be successful while remaining like an open source project and like community support, all that stuff is.
I mean, I think
really cool.
Because we have such a small team, like we always think like, can we do this with less code? Can we do this in a smarter way? Which like we're really focusing on like an end-to-end machine learning approach where like all the video just goes into our neural net and it just tells you where to drive. Like we never get tempted to build all these hard-coded rules like, oh, but what if we make like this police car detector? And then we spent like put a whole team on like the police car detector. And it's like, yeah, but what if the door is open? I guess we need a police car with open door detector. And then suddenly their planning team needs to be able to like, oh, okay, now I see a police car with like an open door. It's like, I need to change my planner rules to go like do this other thing. And then suddenly you have like hundreds or thousands of people working on this complex system and it's just like this never ending thing.
Were you thinking to have like the police car to like slow down your speed at that point, or were you thinking about it from another, like what other rules were you planning to apply?
Yeah, or like I mean, it's like or cones or like there's all these things that change how you drive, but it's I mean, we do this more from a machine learning perspective. Like we just put the videos in, and it's like just drive like a human. Like what would a human do? But this is harder for companies that already promise people a lot of things, or like but next year it's going to be done, or like they have investors, and they want to show progress, and then it's very tempting to do this stuff. Like for us, like we didn't have stuff like traffic lights working for quite a while, and it's like, how do you explain that to an investor? Like you're working on this self-driving car, but you're working on this for 3 years, and you don't have a working traffic light. It's like, what are you doing?
Well, Tesla.
No, but like as long as the driver knows the limitations, right? And you're supposed to be paying attention anyway. Well, like when I've used cruise control, it didn't know about lights. Like if I left cruise control,
you're not supposed to use it. You're not supposed to use it like that. You're not supposed to use it except on the highway.
That's what I'm saying. As long as people know what the expectations are, then there's no problem.
But
that would require people to read things.
For the self-driving car companies, actually working on reels on like cars that can do everything. But for us, we do more like the machine learning approach, and then now we're getting the first results where like our neural network tells us to slow down for a traffic light, even though we never told it explicitly what a traffic light looks like. It's like it just knows, oh, humans stop here because of this thing. And it's like, well, I guess I should stop.
What's the delta here? Yeah. So I just heard about this last night. Have you guys heard about this? Tesla's cars apparently have like and I'm using a specific parlance, a California stop mechanism.
Well, they got recalled for that.
Yes, they did.
Yeah, no, but well, this is what you're saying, that these are specific like rules that are baked in versus just like drive like a human.
Yeah, I mean, it's a little concerning, I guess, since if our system thinks there's going to be a California stop, then it will make a California stop. I mean,
yeah.
Well, if your data's biased there,
the driver
if
should be like
should you drive like a human? Like you see this in these reports, like they get rear-ended all the time, and it's like, yeah, we didn't cause an accident, but it's like, why do you get rear-ended all the time? It's like we used to stop all the time.
we stop where we're supposed to stop.
Yeah.
I mean, I grew up in Mexico, and you do not stop at stop signs because you're gonna get rear-ended. Stoplights, yes, but stop signs are just kind of there.
So there's a Mexico City like stop.
Yeah, exactly.
The Mexico roll then.
Yeah, so and so are these learning from just the individual driver, or are they learning from all of the drivers using OpenAI or not OpenAI? Sorry,
openpilot.
Yeah, it's all everyone who uses openpilot. All their videos get uploaded if they're on Wi-Fi.
Mm-hmm.
Oh, like when you get home, it'll like,
we get all the data, we get all the CAN data from the car, all the sensor data, and then we process that, label it, and like.
So do you use like GPS on that data? Do you like, what kind of privacy protections do you have on personal identifying information?
I mean, the people who use our system know it's a dev kit, and they upload all their data to us. It's basically everything.
Yeah.
Yes, I mean, again, this is the same for everything I say. As long as people know what the expectations are.
Yeah,
we're very clear about that, and it's open source. So if you want to use OpenPilot, not like contribute your data, that's fine. You just comment it out. This is a one-line change.
Okay,
that's pretty cool.
Yeah. I mean, we're very open about it. So
yeah.
So we have one question that we generally ask all of our guests. You might be able to already guess what that question is. What is your favorite tool to use? The one that you can't live without?
That's probably my oscilloscope, I would say.
Oh, nice. Yeah. I mean, yeah, I used mine. I used mine yesterday.
Yeah, I just got a new one. I got like a Sigland, which you can also use with GL Scope client, which I think is really the future of like where this stuff is going. Like, why are there logic analyzers? Why is the scope different? Like, why does all this processing need to be on the scope? It's kind of like the software defined radio of oscilloscopes. Like you just send the data to the computer for further processing. So you can just hook it up to like a CAN bus, and then like you can turn your analog signal into digital, and then you can put like a CAN parser on it, and you like just CAN data from your oscilloscope.
Yeah.
So I've heard of GL Scope client, but can you tell us a little bit about it? Just,
I mean, I'm not a super expert on it. I just started using it, but yeah, it's basically it takes a capture from your scope, and then over Ethernet or USB, it just downloads all the data points, and then you can get it on your computer. You can display it, and then you can build this processing graph that processes it into whatever graph or plot you want.
Cool.
It's kind of like out. New radio. I don't know if you've used that. It's kind of like that, but then for your oscilloscope.
Fortunately. It's getting much better recently, but I tried using New Radio like 6 years ago, and
that's probably the last time I used it as well.
Got my little SDR here that I've been playing with. So
nice.
Cool.
Shall we close out the show?
Yeah, I think that's all I think we covered everything we wanted to cover.
Yeah. So I'll do the outro. Willem, thank you so much for being here today. We really enjoyed. Do you have any last words, or how can people contact you?
If you want to be
if you want to be found.
They can find me on Twitter, PD0WM. It's my Twitter handle.
Great.
Cool.
And yeah, and if you're looking for a job with reverse engineering cars or working on interesting software, you can also always come work at comma.ai.
Oh, nice. Yeah, we can put a link to
Yep.
if there's a jobs page or something.
Yep. Alvaro, where can people find you?
I'm on Twitter at Alvaro Prieto and alvarop.com, the usual.
You can find me at RebelBotGen. If you, the audience, have comments, suggested names for the show, I don't know, find us on Twitter at unnamed_show on Twitter, or hit us up on the comment form, which means we'll check it every couple of years, so your comment will be stale by then.
But Twitter, yeah.
But Twitter. Twitter's the key one. You can also still find us at unnamedre.com if you want to look at the show notes, which generally are really good. I'm surprised how often people refer to those. Let's see. We want to give a shout out to all our patrons. We have a couple new ones, but I don't have the list up here in front of me. I'm so sorry.
Get them next time.
We will get them next time. I swear we will. We still would love to have your thoughts and reviews on your favorite podcasting app, if that's how you listen to us. So iTunes, Stitcher, Spotify, whatever. Please put a review in there. Help people find out about us. And that's all. Until next time.
Thank you so much. Yeah, thank you so much for joining us.
Thank you for having me.
Bye, guys.